Wishes and greetings from Rohini College of Engineering and Technology. Let's continue with the second law of thermodynamics, part 3. In previous session, we have completed up to heat engine. So starts from refrigerator. So refrigerator is a machine or a device which maintains the temperature which is less than atmosphere. So here we have a diagram. They have shown a warm environment where the higher temperature should be less than lower temperature, and below that there is cold refrigerated space, and at the mid portion there is a refrigerator, right? Here the thing is, the work has been given to the system. So here before, the in case of heat engine, we have extracted the work. So the work is the output from the engine. In case of refrigerator, we are giving the work to the system for the process to happen, right? For the refrigerator, we're giving the work as a input. Refrigerator is a device which maintains the temperature below the atmosphere. So therefore, from the hot body, the heat should be extracted. The heat should be extracted by the refrigerator or absorbed by the refrigerator and sent to the sink. Look at the illustration. Here the input is given as, the work done is a input has given to the refrigerator. The refrigerator absorbs the cold from the hot body and sends to the sink. Here the efficiency. So here in case of a heat engine, the familiar term is efficiency. But in case of refrigeration, in refrigeration, the coefficient of performance, COP, is a important term to measure the efficiency of the refrigerator. So here the coefficient of refrigeration is defined as the ratio of desired output or the heat extracted to the work input. Here we know that in case of refrigerator, the work is the input given to the refrigerator, and the amount of heat extracted or else amount of the desired output, that is said to be a heat extracted, QL divided by W net. In that means input, we have given the W as input. In previous case, that means in case of heat engine, the W net is the output we have taken from the heat engine. But in case of refrigerator, the W net, the net work done, has been given as an input to the refrigerator, where W, the work done, net work done, is equal to the temperature of higher level minus the heat of the lower level. So therefore COP is equal to QL divided by QH minus QL, or else we can transfer it to the temperature case. COP is equal to TL by TH minus TL. Heat pump. So heat pump, the major difference between this heat pump and refrigerator, both the concepts are same, but even the refrigerator has maintains the temperature below the atmosphere. Here in case of heat pump, it maintains the temperature of the hot body at the temperature higher than its surroundings. The refrigerator is a device which maintains the temperature below the atmosphere or below the surrounding. In case of heat pump, which maintains the temperature higher than the temperature of the surrounding. This is the major difference between the refrigerator and a heat pump. That was illustrated in the diagram itself. Here, for the heat pump itself, the coefficient of performance is a parameter used to define the efficiency of the heat pump. Here the formula will be COP of heat pump is equal to desired output QH divided by required input, is nothing but the work input given to the system. Here we are going to discuss about the major important law of thermodynamics, is second law of thermodynamics. This second law of thermodynamics completely derives the heat transfer phenomena. The second law of thermodynamics has of two statements. One is a Kelvin Planck statement, another one is a Clausius statement. In Kelvin Planck's statement, he has stated that it is impossible to construct an engine working on a cyclic process whose sole purpose is to convert the heat energy from a thermal reservoir into an equivalent amount of work. So, of course, yes, it is impossible to construct an engine which gives 100% of efficiency. It is not possible at all. So, no engine can give all the amount of heat energy into work. Some sort of losses will be there. Second law imposes all the net heat energy will not be converted to the work energy. Some percentage or some part of the energy getting wasted or lost to the surroundings. This is the Kelvin Planck stated. Here look out the possible and impossible systems according to the Kelvin's Planck statement. In the first diagram, the hot body from the source, it is given to the heat engine. The heat has been given to the heat engine, and the complete source of the complete energy from the hot body is converted to work. It is an impossible system. So practically it is not possible at all, because every system, every thermodynamic system or process having some losses. So therefore, the first diagram is an impossible diagram, impossible system. All the where all the heat energy is converting to work energy. So impossible. So look at the second diagram, the possible one. That means the hot body from the source, the heat energy is given to the engine. The engine converting some part of the heat energy into work energy, and the remaining parts are sent to the surrounding. That means sent to the sink. That means all the heat energy is not converted to work. Some part of energy getting lost to the surrounding or a sink. Therefore, it is a possible system. So here where we are going to look at the Clausius statement and the second law of thermodynamics. So it is impossible. It is impossible to transfer a heat. Simply we can say the heat is always flows from hot body to cold body. So this is the Clausius has stated. This is a statement Clausius has given. To transfer the heat from a body at a lower temperature to a higher temperature, we must need of any external aid. That means hot body to cold body is possible. According to the second law of thermodynamics, the heat is always flows from the hot region to the cold region or hot body to the cold body. So even the heat transfer between the cold body to hot body is not possible without any external device or external heat. That's why here stated it is impossible for a self-acting machine working in a cyclic process to transfer heat from a body at a lower temperature to a body at higher temperature without the aid of external agency. This is Kelvin has stated. So according to the Kelvin statement, according to the Kelvin's Planck Clausius statement, here the hot body source to source, it is not possible because both are hot body. For the Clausius statement to happen, if the two bodies are having two different temperatures alone, it is possible. But here both are the hot body and source. It is not possible to construct a machine likewise. But look at the second diagram. The work is given to the engine or a pump, heat pump. The work is given to the heat pump. The heat pump maintains the temperature of the system higher than the atmosphere, that higher than the surrounding. So there should be a temperature difference. In case of in case of normal heat transfer, the heat is always flow from the higher gradient to the lower gradient. But in case of refrigerator or heat pump, what we are doing? We are transferring the heat from the cold body to the hot body. So therefore, the refrigerator or heat pump, the external devices are needed. Suppose assume without this heat pump, it is not possible. It is not possible to convert the cold body, the temperature or heat from the cold body to the hot body. The system may become impossible without the heat pump. Okay, naturally it won't happen. Naturally it won't happen, right? So no body can be transferred from cold to hot. without any external device called a heat pump, refrigerator, etc. Yes, here we are showing the perpetual motion machine. Perpetual motion machine is a device which violates the first law of thermodynamics. PPM, that is a perpetual motion machine of kind 1. It is a machine of first kind, produces work without the input of energy. It thus violates the first law of thermodynamics and the law of conservation of energy. That means without the input energy, it produces the output work. The perpetual motion machine of kind 1. So therefore it violates the second law. What second law says? Whatever the amount of heat energy given to the system, that may be converted to the work energy. But the perpetual motion machine, without the input energy, it creates the energy, work energy of its own, thus violating the first law. So therefore PMM, the perpetual motion machine, that violates the first law of thermodynamics, and which produces work without the input of energy. Yes, as like PMMK2, perpetual motion machine of kind 2, which violates the second law of thermodynamics. However, the PMM1, the perpetual motion machine of first kind, violates the first law of thermodynamics, which produces the output energy without any input. So same kind, the PMM2, the perpetual motion machine of 2, which violates the second law of thermodynamics, in which the spontaneously it converts the thermal energy into mechanical energy when the thermal energy is equivalent to the work done. So uh, this does not violate the law of conservation of energy. However, it does violate the second law of thermodynamics. So here all the thermal energy, it's spontaneously converting all the thermal energy into mechanical energy. So when the thermal energy is equivalent to the work done, that means it converting all the thermal energy available into the useful work. But what the second law of thermodynamics says, it is not possible to construct an engine which converts all the heat energy into work. Surely it violates the second law of thermodynamics, the PMMK to the machine which spontaneously converting the thermal energy into the mechanical work. So surely it violates the second law of thermodynamics. So thank you. The remaining we can look at in the next session.